We'll try and keep this as interactive as possible. Otherwise, we'll only be here 10 minutes. So, also, hopefully, a lot of you are already familiar with web page test. I wasn't planning on going over the basics too much. Really planning on going through the stuff that's not all that well documented, and giving my aversion to documentation, that's almost everything, other than testing a straight URL. And if we have time, I'll actually go to the Internet Archive Wayback Machine, and you can see my aversion to design as well, with what some of the original versions of web page test looked like. This is just a high level of sort of what I was planning on going through today. The bulk of it, most of the beginning part, is all stuff that you do while you're using web page test interactively. I'm also going to be talking some about the API. There's an interaction API, you can REST API. You can fire stuff, get all sorts of data back directly. And then some of the cool stuff you can do if you run your own private instance. It's all open source, free, BSD license, do whatever you want with it. I just won't support it, but otherwise, feel free to hack on it, do whatever you'd like. And we accept pull requests. It's all up on GitHub, so please contribute back if there's something you want to see. So jumping right in. So one of the first things, yeah, we're not going to spend any time with it looking like this. Pretty much all of the time is going to be spent down here in the advanced settings area. And one of the first things I recommend highly is always run more than one test. Odd number works best because on your results it'll tend to pick the median run, and medians work a lot better if you have an odd number. Otherwise it's going to randomly pick, well, it's not going to be randomly, it's going to pick the faster of the two that it lands between. 9 is good if you want your results faster, and 9 is only good because that's what I limit you to on the public instance. More would be even better. If you want your results faster, 3 or 5 make good numbers. The reason you really want to do more than one is the first run tends to do things like warm up the DNS caches, warm up the server that you're hitting, for example. You're pulling a website, it has to talk to a database. All of that stuff gets warmed up the first time you hit it. I wouldn't ignore the first run. I'd be aware of it and be aware of what it's doing and that it's warming up your caches on the back end while you look at the results. So you have both an idea of what your results look like for when the entire path is basically hot to the server, as well as what it is when it's completely cold and you hit it the first time. So it's not unusual for the first run to have like a really long first byte time on the base page, for example. But when you do get results with more than one run back, and yeah, I've got pre-cooked results for everything, so we don't have to wait for tests to run. So you get a whole bunch of results that look like this, and on a really low-res screen. We'll zoom out. And one of the things, the first sort of buried links that you'll see is right here below the data table. If you run more than one run, you get a plot full results link. And usually you have to sort of scan through the results and see what the load times are. This will give you basically all of the metrics for all of the runs plotted out, first and repeat view. The blue lines or the blue dots are the first view. The red lines, red dots are the repeat view. And then the line is the times for the median run. So you can see how consistent the results were to see if the result you picked is representative of what you're looking for. Usually I'll go down here sort of to the speed index, and yeah, they're all pretty consistent. Number 2 was an outlier. Probably don't want to look at the results for number 2 unless you want to understand why it was an outlier. And into the completely undocumented area of space. Up here, if you look in the URL, it's got median metric equals load time. So pretty much any of the pages on web page test where it picks a median run for you, including the main results page, it's hidden. It doesn't tell you. It's picking the median run based on the load time. You can actually put any median metric in, any metric name in here you want. And then the median metric will be picked based on that metric. So we can take that. And navigating through a test, usually there's a couple of links here. There's sort of 2 headers. The main test result will take you to the main test result page. Or down here, the summary will take you to the link with that has all of the results on it. So right here, this is just the normal URL, and it's going to pick run 3 is the median run of the first view based on page load time. But if we throw median metric speed index, run 6 is the median run. So you can change what it uses to calculate the median run for you and getting you the median results. And this works on any page, whether it be the film strips, the main results page, anywhere where it picks a run for you based on the medians, including the API. So if you want the API to return you a different median, you can pass it the median metric. We'll get to, so I said you could put any valid metric name in. The list of valid metric names to use is also not documented other than in the code and in the results in the API. So yeah, we could call that a to-do list, or I'll show you how to see what the API results look like, and you can just look through there and pick any of the results. And so we're going to be talking about a whole bunch of different things, user timing, custom metrics and stuff. Any metric that comes back in through the API or through the results, even if it's not visible in the UI, can be used for selecting the median metric.
So when you save results out into XML from the test run, it seems like the median metric there is picked based on what? Can you influence that?
So the question was, when you save results out based on the XML results, it picks out a median run as well. So the XML results, and we'll get to the API in a little bit, but it has a section up at the top that has the average, it has the median run, and then it has all of the runs. By default, everything when it picks a median is picking it based on the onload time. This query parameter works on all of the entry points. So the URL for getting the XML result, you can also pass median metric equals speed index, or median metric equals bytes in, or whatever, and that median will be picked based on that criteria. So like I said, well deep into undocumented territory. Okay, so visual comparisons. Hopefully, this is slightly less esoteric. The main entry point, sort of the easy entry point for visual comparisons is here. You'll go in, you'll add a bunch of URLs. It'll run with a whole bunch of default parameters, and it'll give you your test results. Usually what you want to do is you want to test very specific configurations against each other, like what is my site loaded on Chrome versus Firefox versus mobile versus desktop or whatever. And there's sort of no easy way to build all of that. So what you end up doing is you have to run all of the individual things that you care about. And by the way, this works a whole lot better if you're logged in. So in Web Page Test, up here in the top right corner, there's a login button and a register button. You can either log in, there should be a login with Google. Oh, yep, there it is. So it'll either OAuth with Google, or there's also a forums area in Web Page Test where there's all sorts of performance discussions. If you register with an account there, that account carries forward to the Web Page Test UI. The main reason that logging in helps is tracking your test history. It can either be tracked by a cookie in your browser, which is useless if you cross browsers or you clear your cache frequently, or the browser decides to forget who it was. Or if you log in, it can track your test history based on your login across your devices. So your test history is really critical to doing comparisons. So let's see, so I sort of force a habit. I used to work at AOL. I do a lot of tests with AOL as my defaults. One other thing you're really going to want to do, especially when you're doing a comparison, is label your tests. It makes it a whole lot easier to find them later. It also makes the labels that you put in here show up when you decide to do a comparison. So like I can say this is Moto G. And I know I said never do just one test, but and let's go back and say desktop. Actually, let's say Chrome desktop. Hopefully I had video checked on both of those. Yeah, usually it'll remember, if you ever check the video checkbox, it'll remember that setting next time you come back, so it'll follow you. Once you've run the configurations that you want, you've gotten the results, the individual results you want, what you do is you go into the test history, and now since you're logged in, it will show you the history of the tests that you have chosen to run. And you can pick out, like here it's got the Chrome versus Moto G for the www.aol.com. You check the ones that you want to compare, and you click the compare button at the top. And now we're going to Martha Stewart it to pre-cooked results. And then you end up with the film strip comparison that has the multiple configurations that you tested. And it can be anything, you can test with ads, without ads, SPOF, no SPOF, browsers against each other, AOL versus Yahoo, US versus UK, pretty much anything up to, I think the comparison works up to about 9 different pages you can look at the same time. Actually, you can look at an unlimited number in this view, although it becomes unwieldy. When you create a video, you can look up to 9 at a time. And then the labels, clearly I didn't label these. This is The Guardian versus CNN.com. And it defaults to just showing you the URL, which works fine if you're comparing sites against each other. If you're comparing a given site in multiple locations, it gets to be kind of difficult to see, okay, which one of these is the UK, which one of these is the US. That's why I highly recommend labeling them. If you forget to label them, or you want to tweak things, so right here up at the top, we've got the URL for the results for the comparison page, and it's not terribly anything fancy. Everything in web page test is pretty much driven by a test ID, and that's what they look like. It's pretty much the date followed by random stuff. It's kind of a hash and buckets and stuff like that. But all this comparison test URL is standard and doesn't change. The only thing that changes is which tests you choose to compare. So you can throw in, if you happen to have the test IDs for other things that you want to compare, you just throw the test IDs in there and it'll go ahead and compare them for you. But the URL will also take other things. So it's a comma delimited list. It also, right now, it defaults to picking the first view run, the uncached view of the median. So once again, we have a page that's selecting median. If you want it to pick median based on a metric other than the page load time, you can pass median metric equals speed index or whatever, and it'll pick a different run. However, there's also a bunch of things you can hack onto each one of those test IDs if you want to further customize it. You can tell it which run. If you went through and you plotted full results and you know, okay, or if you looked at the film strips for individual runs, one of the things that happens fairly often when I'm comparing a site in multiple locations or in multiple browsers is I'll get different ads. And I try to pick a representative page load that has the same ad across the same tests so you can get pretty much the exact same experience across all of them. So you go, okay, this one I really need run number 4. This test I really need run number 7. So in addition to the test ID, you can pass like -R:3, which will give you run number 3 for that given test. You can do first view versus repeat view by passing -C:0. C is for cached, 0 is for not cached, 1 is for cached. So if you pass a C:1, you can give it a repeat view that you're looking at in the comparison view. The E is a particularly interesting one where once you're looking at a film strip, you can go, okay, that's interesting. You know, the last absolute thing that changed is all the way over here, but it was really done, let's say, here at 7.5 seconds. I want to end this video at that point in time. You can specify for each one of the tests an explicit endpoint for the comparison, so you're not stuck with whatever web page test decides to display. And then, of course, if you forgot to label them, you can pass -L and an arbitrary label. So you can go through and relabel them after the fact. It creates kind of a long, unwieldy URL, but it works a whole lot better than not being able to tell what the tests are. One thing that's probably not obvious, since they're not blue or underlined, is the labels to the left of the film strips are all links back to each one of those test results. And it's a link back to the actual run that's being displayed in the film strip. So if you forget which one is which configuration, like is this the UK, is this the US, you can go back to the actual test result, see where it was run from. You can say, hey, that's Moto G Guardian, so go through and -L. Moto G Guardian. And then your labels get updated. And all of that tracks with you when you go to create the video. Let me go. Also, well, here I've got like all things, got a pre-cooked version of it that says, so this one I did the Guardian first view versus repeat view, so you can see what it looked like, how much faster does it load in a repeat view. And I had explicit endpoints to get it to end where I wanted it to. So you can see they get most of the content up a whole lot faster, and then the whole page stops 4.2 seconds versus 7.3 seconds. And this is the first time it actually displays everything above the page. One of the interesting things here, if you look at the full thing, let's 60 frames per second to really draw it out. You have to look kind of close, but down here below the fold, or not below the fold, but right below the image, there's the text for the article, and then the text for the article goes away, and then it comes back. And that's when they're applying the font, the custom font. So we'll talk about custom fonts a little bit later, but the content disappeared while it was getting applied. It looks like from 14.5 seconds to 15.2 seconds, so almost 700, 800 milliseconds of blank content while it's applying the font. I chose to end the comparison film strip before the font was applied in both cases, but both cases have a blank out. And then you can go ahead and create the video, and it uses whatever parameters you defined when you set up the film strip. It'll go ahead and use the exact same parameters for the video. So the labels, the endpoints, the specific runs, whatever you've configured, it'll go ahead and create a video for you. And these tend to work best if you're trying to demo to a boss and say, hey, look how much faster we are on repeat view load, or look how much faster this other company is than us, or how much better our new version is than our old version, for example. Everyone still with me? Okay. All right, so we did the film strips the way we want them. So this is the Guardian versus CNN, for example. I don't know, it's history, I guess, that we have to pick on CNN every time. And the Guardian, if you're not aware, they've done a whole lot of work on building a really fast, really responsive mobile website, which is one of the reasons I pull them in here. They're a good example for a fast site. But they're also a good example of why performance work is never done, because there's still things that could be better from a performance perspective anyway. This one's particularly interesting in that, I guess as part of rendering, Chrome had a couple of blank tiles when it first rendered the screen. So we have CNN versus The Guardian. We'll go ahead and create the video. We had our explicit endpoints. You can see from the user experience, the Guardian content starts to load a whole lot sooner. They've got a lot more content displayed to the user sooner. The CNN content all sort of pops, but it actually finishes loading before the Guardian content does. And Steve.
What some of the film strip images have a gold border around them. What's that mean?
The gold border, also known as the Steve Souders feature. So it's not a plant question at all. The gold border is when screen content has changed. So you can pretty much, when you're looking at a film strip, there's going to be a whole lot of repeated frames where nothing happens. It's amazing how static web pages are while they're loading. Usually you'll only see like 4 different paint events where content actually changes on the screen. Even if you're loading like dozens of images and a whole bunch of text, it's just the way the browsers work. They're loading all of that content, they present it every now and then. And the gold borders around them tell you at what point the frame changed from what was previously displayed. And usually what I'll end up doing, so this one's obvious, right? The white box went away. This one, hopefully we can actually see. I'll usually end up opening the frames in 2 different tabs and just kind of bounce back and forth. And in this case, it's that itty-bitty bit of scroll bar on the top right. So this is the easiest way I've found to tell what changed in the content you're looking at. Just open them up in tabs and flip back and forth and what jumps out at you is changing. Because more often than not, you'll get someone saying, hey, you know, the end of the visual paint is way back here, but I don't see anything that changed on the screen. Steve, again.
Have you ever analyzed the average number of paint events on pages?
Have we ever analyzed the number of paint events on average on pages? No. That might be an interesting study for the HTTP archive. Back there. Can you call out where the DOM onload event is? So we'll jump ahead a little bit, I guess. Actually, this is a mobile test, so I'm not recording DOM onload. Let me... Because I haven't implemented it yet. So, as you're probably aware, the state of mobile testing, it used to be really atrocious, i.e. non-existent. It's gotten a little better. It's still not quite up to where desktop is. We're hoping to make more progress on that. Let me change this to fully loaded. So usually in the waterfalls, at least on web page test, there's these two events, or two sort of wider bars. The blue one is the onload event, and the width of it is how long the JavaScript code attached to the onload event takes to execute. So wide bar is bad, thin bar is good. Blue one's on load, purple one is DOM content loaded. And if you want to sync up what happens on the screen to the actual DOM content loaded, the film strip and the waterfall are synchronized. And so there's this red bar that tracks along the waterfall that tracks along with the left edge of the film strip. So whatever's on the left edge of the film strip, it's what was displayed on the waterfall at that point in time. And yay, the start render time lines up with the first film strip that has an image. So if you want to see what DOM content loaded like, you just go sort of to the purple bar in the waterfall. So the red line overlays the purple bar, and you can see what the image looked like at that point in time. In the case of CNN, it's pretty... I think this was CNN. Oh, this was AOL. It's pretty empty still at that point. And so this is a good way, for example, to help baseline your RUM metrics versus the visual experience as well. So if you're reporting the DOM content loaded event back in your RUM metrics and you want to sort of know what's the user experience at that point in time, you can go into the film strip, do both probably recommend looking at both a first view and a repeat view. And so right here, that's the test ID. We'll do cached 1. Since you know the super secret, I ran first view only, so we don't have repeat view data. If we had repeat view data, this would give you the repeat view film strip. You can see sort of where the DOM content loaded, because it's entirely possible for a DOM content loaded on a repeat view if it already had the images and the JavaScript and everything else in the cache. It could have displayed a whole lot more content, for example, in a repeat view. So the actual user experience in the field would be somewhere between the two, but not terribly deterministic, which is sort of one of the problems we have with taking the technical metrics that we have from the browsers and translating them into user experiences. Still good? Oh, right back here.
Back on the gold border feature, how are you detecting when the images or content changes on the page?
The gold border, how are we detecting when the images or the content changed? So depending on how it's, well, actually in both cases we pretty much do it the same way. For the desktop browsers, we capture a screenshot every 100 milliseconds, and then at the end of the test, we dedupe them. We do pixel by pixel, we compare the images against each other. Any ones that are repeats, we throw out. And in the case of mobile, we record, I think it's an 8 megabit video stream off of the device. And we dedupe, we extract the individual frames, we dedupe them, and then we also store only the ones that have changed. So on the server, it actually only stores the frames that have the orange border around them. When you're displaying the film strips, it's just repeating. You can probably see. So this one's ms_002409.jpg. This one is the exact same file. So it's actually just repeating the frames that didn't change. But it is doing within the viewport a pixel-by-pixel match of the images and discarding duplicates. I say within the viewport because, like in the mobile case, you don't want to necessarily update that whenever the clock changes. And we're also skipping the progress bar, which is something I'm kind of torn on, so I work on Chrome for part of my time, and I'd really like to, one of the things I'm trying to fix is when the progress bar ends, and I'd kind of want that to be part of the video, but as users of the content, you really don't care that much about the progress bar. You care about the completeness of the content. So the progress bar is also excluded when we're doing the diff of the frames. Alrighty. So now into completely undocumented territory, unless you look through the code. It's all in GitHub, so there's probably even stuff that I'm not covering here that's buried in the code. But usually the screenshots, when we take screenshots for a test, they're sort of the video screenshots, where here, fairly low resolution. I think they compress down to like JPEG quality 30, mostly to conserve disk space on the server. And in here we have the screenshots of what the page looked like at, there's usually a start render, but what it looked like at start render, what it looked like at onload, and what it looked like at the end of the test fully loaded. And those are usually resampled down to be at max 400 pixels, either width or height, depending on if it's a tall or a wide image. And these are also compressed. I think these are quality level 45 or something like that. But they're not terribly useful if you're looking for really granular details. One of the things that you can do is you can capture, so these parameters are actually documented for the API. PNG SS, PNG screenshot equals 1, will capture full resolution PNG screenshots of when the test, like start render and the onload event, so you can see pixel by pixel exactly what did the content look like. Sometimes this gets used for if you're testing like an accelerator or something that's manipulating the page content. Did it actually break the page? Is the page content identical to what it looked like before? Or exactly which individual pixel changed? And sometimes we get things where pixels shift by like 1 pixel. So it's fairly handy to have. And the other one is, this one, the PNG screenshot, does not impact the video frames though. Mostly because I haven't implemented that yet, again. And I'm scared about the amount of space it'll take on the server. But so we plan on having a way of storing higher resolution versions of the video frames. But the IQ is image quality. That's a JPEG compression level. Don't bother trying to set it to 100. That doesn't work. I think like 95 is as high as you can reasonably go, or it'll cap it for you. But you can capture higher quality images, and the image quality impacts both the video frames as well as JPEG screenshots if you're taking JPEG screenshots. So if you want higher quality video frames, like you're doing a presentation to higher ups, or if you actually want to get more detail about what changed between the video frames, you can boost them. Usually, like I said, it's documented for the API. It's also, if you go to the main webpagetest.org, you can pass those two as query parameters. And there's a hidden form field that's not exposed anywhere in the UI that if you pass those as query parameters, it sets it in the form field. So whatever test you run will use whatever you passed into the form up here. So through the UI, you can run tests which use PNG screenshots or higher image quality by passing those in as parameters. Please don't abuse it too much. So here we've got the regular resolution results. Let's see. We'll go to screenshots. So that's what the regular screenshot looked like. And the PNG, forever to load, but yeah, so that's the full resolution. Oh yeah, I zoomed out the browser. So that's actually a 1024 768 viewport, full PNG. You can do whatever you want with the images. And all of these, we'll get to the API a little bit later, but all of these are available for download through the API as well. Question?
When you say undocumented, are these very parameters documented anywhere?
So when I say undocumented, are these query parameters documented anywhere? Sort of by definition, no. They are now because they're in the PowerPoint or in the PDF deck. and they are in the code. The query parameters themselves, these two are documented in the API. So there's let me pull up. So this is the documentation for what it is for web page tests. There's a RESTful APIs, and there's a whole bunch of parameters, and the PNGSS and like here, PNGSS and image quality are both documented here. The fact that you can use them as query parameters on the main page and have that propagate to the test results is not documented anywhere, which is why you're here in the Power Users session, learning about all the cool tips that I'm only telling you. Yeah, there's that. Sorry, go ahead.
If you're running a private estate, is it possible to change the default settings using quality and resolution?
So if you're running a private test agent, is it possible to change these default configurations? Yes. Both of those can be specified in the settings ini. So if you specify PNGSS equals 1 in the settings ini, it will always capture PNG screenshots. And IQ, you can set the default image quality through the settings ini. Yes. Chrome timelines. So, where are we? Let's close some tabs, get some sanity back. So over here in the Chrome tab, there's some features that are specific to Chrome only when you're running tests. One of them that I use fairly often is this DevTools timeline. If you're used to the F12 developer tools in Chrome and you record a timeline there, this actually records one of those while it's running your test as well. It's safer to just go ahead and turn it on here. The call stacks, you can also include a call stack so that when you're looking through the timeline, it'll tell you how did the code get to the point where it's executing this JavaScript or whatever. It adds a little bit of overhead on mobile. It's worth testing with and without to see if it's even measurable on your results page. On like a super fast, super cached page, it might show up as a 5% hit to capture the call stacks as it's recording the timeline. But you can turn it on separately. Usually, if you're doing mobile testing, the timelines will always be captured if you're also doing video, because we actually need some of the timeline data to be able to sync things up with the video and the waterfall. On desktop, you actually have to explicitly go here and turn it on. So it's safer to just go and turn it on if you want to capture a timeline. And we will see what those look like. Okay, so this is a test I ran of the Guardian again, with timelines enabled. There's a couple of places that it shows up. So over here on the left of the waterfall, you'll get a collection of different links. The processing breakdown will tell you, so it'll go through the timeline and tell you how much of the main thread, how much time the main thread spent doing stuff. And what that stuff is depends on what the timeline's reporting, but it's usually JavaScript stuff, whether it's parsing the JavaScript or executing the JavaScript. HTML stuff, parsing the HTML, or sort of graphic stuff. We'll call it layout, paint, that kind of stuff. All of these colors match what you get in the F12 DevTools timeline, so hopefully they look fairly familiar and not too alien. The orange one's the one that you'll usually see a lot. That's JavaScript. So watch out for that. And it gives you two different views of it. Up at the top, it's of all of the time that it was doing something, how much time did it spend doing these different activities? And then on the left, it breaks it down by high-level category, so script stuff, rendering, painting, this is HTML, so loading, and then other undocumented or uninstrumented stuff. And then on the right, it breaks it down by actual categories within those. So like the JavaScript breaks down roughly equally into evaluate script is actually parsing the script as it came in. And then this one's function call. That's actually executing JavaScript. So you can see this actually spends more time parsing the JavaScript that it received and figuring out what to do with it than actually running the JavaScript. And out of all of the time that the browser was doing stuff, script was what it was doing most of the time. Then the same version of the charts are down below. This one includes idle time. So in all of the time spent loading, how much of the time was it actually spent busy? And when the main thread's busy, you can't interact with the page. So this is a bad thing, right? You want to minimize how much it's doing that. And this just adds the idle time, how much it isn't doing. Yes, up here. So how do we get this data from the server? Probably easiest if I just show you what the timeline looks like. So over here on the left, there's two other links. You can download a timeline, which is a JSON file. You can load it up in your Chrome DevTools locally. So like if you go into F12 timeline, you can load timeline data, and you can load the JSON file. Or what I usually end up doing, there's a view link which opens it in an embedded timeline viewer in the browser. And so this link is shareable. I wouldn't bet that it would actually work in anything other than Chrome and maybe Safari, mostly because this actually took all of the timeline UI code from Chrome and is just exposing it. And I'm pretty sure they weren't trying to do cross-browser compatible stuff when they were building the Chrome-specific timeline code. So these are all of the timeline events that get recorded in the browser. The raw files, let me just show you what they look like. So the raw files basically look like this. There are a whole bunch of events, and each event is, they have different categories. I was parsing HTML, I was parsing JavaScript, I was executing JavaScript. And all web page test is doing is parsing through all of those JSON events, looking at the start and end times for when it was executing, adding those up across the whole time. And then in here, what you can see is you can actually get as the page was loading, this is like, so the orange was the script execution and parsing stuff, so we'll zoom in on the script. You see here it was evaluating Bootstrap. So parsing the JavaScript, the Bootstrap JavaScript was fairly painful. Looks like it took 439 milliseconds. One thing you definitely want to do is you want to expand when you're looking at like a script tag, you want to expand it because, let's see if this one, great, so it doesn't want to expand. Because it doesn't necessarily mean that it was spending all of its time actually doing the JavaScript execution. So you want to look for any blocks in there where it might have been triggering layout. One of the things that's not uncommon if you have script that's running, particularly like on DOM content loaded, is it'll start going through the page and it'll start getting dimensions and positions for things on the page. Things like lazy image loaders, where you want to display images as they scroll into view. It'll be going through the entire DOM, looking at the position of each image element. And when it goes to query the position of each one of those image elements, it forces a layout in the browser. And so the actual execution of the JavaScript might not be the expensive part. It might be the layout that it triggers. In this case, it's actually doing some HTML parsing, so it must have done like an inner HTML in the JavaScript. So while it's the JavaScript's fault that happened, it's not necessarily the JavaScript code itself that's taking the time. And so this is actually one of the reasons I love doing testing with Chrome, is because of the richness of the data that we get back out when we do the tests on web page tests. You can get not only this is the resources that loaded, we can get the full timeline of everything that happened to load the page. Like this case, it looks like the script took forever, but it's actually doing a whole bunch of, I think these are data URIs. Yeah, so it's putting in a whole bunch of placeholder images. So it's the inserting of all of those placeholder images on the page that's fairly expensive to do. Let's see. So the other place that this will show up, let's see if I have some more waterfalls. So down here at the bottom of the waterfall, you can't see it too clearly in that view, but we'll zoom in a little more. It will also take the timeline events, and it'll use the same color codes. And it breaks so the timeline events also get tagged with which browser thread they're running on. And this is very Chrome specific. But the main thread is one of the ones you want to be really careful of because that's the one that the user interacts with. And then there's a background thread that Chrome uses for doing some graphics layout and painting and stuff. And what this does is almost a CPU utilization graph, but it takes those timeline events and the duration of how long they took to run, and it plots them across below the waterfall so you can see when it was spending its time executing JavaScript. Sort of eyeball it. You can say, hey, that's an awful lot of orange there. Maybe I should look into that. And that's a whole lot of orange that's happening right when it's doing, in this case, the onload event. So it's not terribly surprising, but they have a bunch of JavaScript attached to the onload event. And then when you see something here that you want to dig into more, you can hop over to the actual timeline view. Look for the, okay, right around 6.5, 7 seconds is what we wanted to look at. That was run number 4. So we'll go, and we'll go, okay, 6.5. That's this orange right here. So this chunk of JavaScript right here is what was showing up in there. And in the Chrome DevTools timeline, you sort of, what you do up here on the top view changes the view of what you're looking at down below, which is why you sort of see me moving the scrubbers to either side of the events that I'm interested in. And then you can see, yeah, so that's the bootstrap evaluation and execution that's happening there. Still good? Still with me? Okay, good. We must go deeper. And also, they show up in the film strip view. And one thing you'll probably notice is the coloring on the waterfalls. Thank you again, Steve. We've been trying to standardize the colors. I haven't quite gone to. The main web page test waterfalls basically look like you've got sort of your DNS is kind of a grayish, socket connects orange, time to first byte's green, and then content downloading is blue. But you can't tell what the actual content is. In the film strip view, we have sort of the more modern version of the waterfalls, where it includes the type of content. So scripts show up as orange, CSS shows up as purple, HTML shows up as blue, images show up as green. So you can sort of well, I think I had those backwards. CSS shows up as green, images show up as purple. Otherwise, there's a whole lot of CSS on that page. And this gives you a really quick way to eyeball when things are loading and sort of know the execution. Hey, I've got an awful lot of JavaScript loading there at the beginning of the page, if you see like a whole bunch of these orange bars. We will eventually move the main waterfalls over to use this color scheme. It's one of those things where I'm just scared of upsetting a lot of people who are used to looking at the old color schemes. But we're trying to, if you'll notice, if you use test pages or sites other than web page test for doing performance testing, they have completely different waterfall color schemes. And we're hoping to standardize on like the MIME color scheme across all of tools. So when you look at one waterfall, whether you look at it in HARView or Keynote or Gomez or wherever, you can still look at the same thing and understand what's happening. But down at the bottom of the film strip view, you also have the script execution, the timeline events. One of the really interesting ones is these green events are the paint events. So you can see, when is it? Scrub. Okay, so like 3.1 seconds. The first content showed up. It actually didn't have to do a whole lot of work. But then right after that, it's doing a whole lot of work loading stuff. And my guess is that's the work to get the main image displayed. So you can sort of see what it takes even after the image is delivered or the content is delivered. And in the case of The Guardian, like I said, it's super optimized, where the main HTML resource has all of the necessary CSS for the above the fold inline, and the main image is a data URI inline. So as soon as the HTML comes back, the browser has everything it needs to render the above the fold page. But it doesn't actually render the above the fold image until like half a second later, because that's how long it took. And this is on a Moto G mobile device. So that's how long it actually took the Moto G to take that image data URI rasterize it as an image, and get it displayed to the screen.